All right, so again, my name is Professor Lajimi, and I got my PhD in Systems Design and Engineering from University of Waterloo. So let's continue talking about multivariable control. This is an introduction yet on multivariable control. So let's continue on singular directions and conditioning. Let's consider an example. 5G is our matrix G5432. Obviously, G is the it's already been evaluated at certain omega, for example, and the singular value decomposition is U and sigma and V subscript H. And recall this from earlier exercises. Yeah, I've already seen this numerically. Now we interpret that geometrically. There are two orthogonal directions. One is strongly amplified and the other is strongly attenuated. So we can already see that we have a 7.3.3 and then we have a 0.2.72, which essentially means that in that direction, this direction is a strongly attenuated. Same. So we have same system, same actuators, radically different effectiveness depending on direction. So let's continue. So the weakest input direction is V mean is minus 0.608 and 0.794, and sigma mean is 0.272. and recall what sigma mean was. Go back to the notes and see how we computed sigma mean. There's nothing strange here because we talked about the GD2 norm, and then we talked about that for unit input and then computed. Then we found the minimum, the sigma minimum. This is essentially a this essentially shows how the G matrix essentially transforms the input to the weakest direction, right? So we have that sigma mean, and then we find that how sigma mean is computed. Let me just give me a moment. Sorry, I think I missed one slide here because I had sigma max before sigma mean, and then so I'm gonna go back to sigma mean, and then that's what's strange it was. And then let's talk about sigma max, the strongest input direction. So we have V max 0.794 and then 0.608, and then compute sigma max as maximum 2 norm GD, and D was the input. This is a specific ratio of actuator inputs. Not use actuator 1 or use actuator 2, but rather use a combination of two actuators to get this maximum sigma max or maximum amplification. So in other words, when inputs are amplified in this ratio, their effects reinforce each other. And then we have the sigma mean, the weakest input direction we mean is minus 0.608 and 0.794, and then we get sigma mean as 0.272, and that's the minimum or the worst case scenario, or not the worst case scenario, sorry. Yeah, the worst case scenario it might be thought of the worst case scenario because in this direction it's it's significantly attenuated. The input would be significantly attenuated, and essentially we experience some sort of cancellation. Large individual inputs can still produce tiny outputs. It's a tiny output. So along this direction, the inputs largely cancel, producing very little net output. Let's go to the next. And let's talk also about non-uniqueness of singular vectors. I apologize. Singular vectors may be multiplied by any complex scalars, C, with norm or magnitude of C equal to 1. And why is that? Because only direction matters. Sign or absolute phase is irrelevant. This explains why software tools may return different signs, because sign doesn't really matter. And then since both inputs influence both outputs, the system is interactive. So in this example, we had 0.794608, and then we had minus 608, and then 794. So what happens is, if you think about these two inputs, we can see that along a direction which is kind of points in the opposite direction of the first one, or not the opposite direction. Along this direction, we have the minimum output, and then since both inputs influence both outputs, the system is interactive. This interaction means that you cannot tune channels independently. You cannot tune output in certain channel along certain direction independently, because that's going to affect the other input, the other output. So, and since both inputs influence both outputs, the system is interactable. Large off-diagonal terms indicate a strong coupling between channels. The larger the off-diagonal terms are, as it indicates the larger coupling and the stronger coupling between channels. The diagonal terms essentially correlate each input to its corresponding outputs, but off-diagonal terms indicate the strong coupling between each channels. The system for our system is also ill-conditioned, because the ratio of sigma max to sigma mean is 27. Some input combinations are roughly 27 times more effective than others, making the system sensitive to uncertainty, right? This sigma max, because the ratio is so large, it essentially means that the system is ill-conditioned, meaning that some inputs affect outputs out of proportion. So it amplifies the some input combinations are roughly 27 times more effective in terms of the magnitude of the output, making the system naturally more sensitive to some input combinations. 27 is very large for a simple 2x2 system. Let's think about some physical analogy. Shopping cart example, a strong direction, meaning that if you push forward, and then moderate direction, pushing sideways, and then weak directions, lifting upwards. So because a shopping cart is an example of a MO system, in that they have some strong directions. If you push them forwards, you see some strong reactions, moderate directions pushing sideways, and if you have already probably tried that and you've already seen that. If not, you can try it. And then you have weak directions, meaning that lifting upwards. So you may apply same input with the same energy, say 1 0 0 0 1 0 and 0 0 1, same energy, same unit energy, but then you get wildly different motions. The same force magnitude produces very different motions, and depending on direction, exactly the idea that depending on the direction, and that's exactly the same idea of singular directions. To move the system along a weak direction, very large inputs are required. So it naturally means that if the system transfer function essentially reacts in a way that it attenuates the input energy in certain directions, then you need the larger input in that direction to create motion. So to move a system along that weak direction, very large inputs are required. And small directional errors cause large unintended motion along strong directions. That also makes sense. That's completely logical. Now let's take another look at another example, a steady state example. For example, a distillation column. We have already talked about some example about distillation column, which is used to, for example, separate two gases from each other. The transfer matrix is, for example, 87.8 minus 86.4, 108.2, and minus 109.6. This is essentially a classic real industrial process, not academic, so it's pragmatic and practical. All entries are large, so if at first look you see that all entries are large, and then control should be easy, right? Because you already have all these large entries. There's no closeness to the essentially it responds properly to your input. That's what you expect. You don't expect it to not respond properly or large enough when you excite the system along various directions. But singular values reveal that sigma max is 197.2, and then sigma mean is 139, and gamma is the ratio of sigma max to sigma mean is 142, which is extremely large. Sigma mean and sigma max are easy to find, right? Because you had the GD to norm, and then you needed to find the maximum of that, the minimum of that. For unit energy input, so you pre-multiply G to your unit energy input, say 10 and 01, and then you find the sigma max and sigma mean, just to remind you. And then emphasize, and I'd like to emphasize on that the system is a condition, that the ratio, this extremely large ratio of the sigma max to sigma mean means the system is ill conditioned. And then so what it means is some input combinations nearly cancel while others amplify dramatically. The physical interpretation of that is that increasing L and V together causes little change. Increasing V minus L produces large composition changes. In other words, internal flows counteract each other, net imbalance, dominant system behavior. So what it means is that The key takeaways are singular values quantify interaction strength, and large condition number implies fragile control. Directional uncertainty leads to large unintended responses. So direction matters, conditioning matters, and the singular values reveal both. So singular values take both direction and conditioning into account. Next, we're going to talk about frequency-dependent singular value plots, MIM, or both type analysis, similar to both type analysis in SISO systems. So singular value both plots replace SISO magnitude plots, and then we're going to talk about that in the next lesson. Or thank you for paying attention. Let's see you soon.